What is up, guys? Coming to you with another video here, and today we're going to be going over resin selection and how I choose between the different resins that I have at my disposal and what you guys can do or use this information in your day-to-day to get the most out of your systems and your repairs. So jumping into it, the first question is, what is a resin? And in this case, with epoxies, which is predominantly what I deal with, the resin is plain and simply the part A and the part B. You have both sides. Now for us, a part A side would be your epoxy side, and your part B would be your cure side, which is most commonly some sort of amine, and there's a lot of different types there, which is a whole separate chemistry discussion, and we'll leave that aside. But that is in essence what the resin is, or in some cases it could be called the binder. But that is what that is, and for a lot of you guys that are used to seeing your glass flake filled systems or your ceramic systems or anything with some additives, the resin is what is actually holding in those additives so that they can do what they do. In the case of abrasion, they're holding in ceramics. In the case of chemical resistance, they're holding in the glass flake, and that is what the resin is designed to do, and put that barrier between the substrate and whatever's in that system. Now, the way I like to work through this is to first just assess what are we protecting against. And within that, there are three main categories. The first one being corrosion control, the second one being chemical attack, and the third one being abrasion or erosion, or wear. A lot of people call it different things. I generally just say abrasion for me. Don't know if that's the perfectly correct term, but that's what I say. And those are what we're looking at when we're first selecting the resin, independent of what additives are going in or anything like that, is what are we protecting against. Now, as we jump into the next slide here, corrosion control, or just corrosion in general, actually contains chemical attack in it, but I split those out to be more deliberate in what we're talking about. And when I'm looking at this, if we're looking at it in terms of corrosion or generalized corrosion, I'm looking for, are we dealing with any atmospheric issues or any moisture? Think corrosion under insulation or anything like that, where it's not necessarily a chemical doing the work, but it is just, hey, we have a corrosion problem. The system is rusting and we need to protect against it. As we switch to chemical attack, this is where things get much more tricky, because we're looking at, is it a high pH, is it a low pH, high being your alkaline solutions, low being your acidic solutions. Do we have a number of different chemicals in there? Sometimes it could be, hey, there's just water in the system, or it's water and sulfuric, or it's all sulfuric, or it's like a flare line or something like that, where we have a number of different chemicals floating around in it. This is where it gets tricky in evaluating, will this resin hold up to all of those chemicals that are within that system. And then lastly, again, this is a massively common theme on this channel, but are we dealing with abrasion and or erosion? And really that's, do we have high solids in the system? Do we have any abrasive particulate? Or is it just a high energy system? Right? There's not necessarily anything abrasive in water, but water can erode rock. Just look at the Grand Canyon. And so that's where we're looking at all these different things to decide on what our resin is going to be for that application. All right, so let's build our perfect resin. The joke's on us. There is no perfect resin. Okay, but seriously, specific to epoxies, when we're looking at building our resin system, from the epoxy side, we have three main types we can pick from. We have our bisphenol A, which we commonly say bis A. We have our bisphenol F, or bis F, and then we have our Novolac, which is just a derivative of the bisphenol F, but is a step up in chemical resistance. And so those are our three main types. And for us, a good rule of thumb is, with your bis A being your general purpose, bis F is going to offer more chemical resistance, and Novolac even more than that, as well as better mechanical properties. And so that's just a good way to follow, or going from general purpose to specialty, being bis A, bis F, and Novolac being the top. Now, as always, that doesn't mean that the Novolac is the best epoxy. It just means if we're looking at something real aggressive chemically or mechanically, it would be the best for that, but it doesn't mean it is all out the best epoxy. Now, switching to the other side, the nice thing with epoxies is we can formulate both sides of the equation. So we have our epoxy side, and then we have our cure side, which are generally amines that we're going to be cured with. And so with those, we have three types, which are aliphatic, cycloaliphatic, and aromatic. Now with these, I'm going to leave the chemistry aside, partially because I'm not perfectly versed in it, but I have some general rules that I follow, and I lean on some chemists when we're looking to make a recommendation. And so with that, in the general purpose section is where I'll put the aliphatic, and then stepping up in chemical resistance as well as mechanical properties, we move into cycloaliphatic and then our aromatics. And just following along with the epoxy side, so kind of the bottom level would be a bis A with an aliphatic, and the top would be a Novolac with an aromatic. Now that doesn't mean that the top is the best, that's just from general purpose to uber specialty. Hey, we have something real aggressive that we need to defend against. That doesn't mean that this one would do well down here in a particular application if we need some other properties. Which brings me to this. Even at baseline, any epoxy can still be a good epoxy. Again, it just depends on what we're trying to do. If you need something with good to moderate chemical resistance, but with a little bit of flexibility or a little bit of give, if we go with a full-on Novolac system, it might be too rigid and end up cracking, and then the system itself will fail, not because the epoxy couldn't resist what we needed it to, but because the epoxy wasn't on the equipment anymore and it fell off. And so to just bring this all together, the three goals when we're going through the resin selection is, one, look at chemical resistance. And again, I use this not as a bad system, but as the baseline with the bis A or your general purpose epoxies, is start there, and do we need to increase chemical resistance, yes or no, and that will determine where we go. The next one is, do we need to increase mechanical strength, and that can either be stepping up on the epoxy side or adjusting the cure package on the amine side to achieve the properties that we're looking for. And then lastly would be, are we good at a baseline temperature of say 100 degrees Fahrenheit for this system, or do we need to increase that to say 150 or 200 or 250 or 300 or 350? What do we need to achieve? Now, as all three of these move up, we start ruling out resins, but that's the way we go through it. Is one, what chemicals do we need to protect against? Two, what mechanical properties do we need, if any? And three, what temperature stability do we need, if any? So I hope this was helpful for you guys. Again, there is no best. It just depends on what you guys are trying to achieve. Even if the best coating would work for an application, the general purpose might work great, and it's going to save you a boatload of money, especially on a big project, if you just don't need the Bugatti of the system to get it done. So hope this was helpful for you guys. If you have any questions, drop me a comment below and I will get to you as soon as I can. As always, appreciate you guys. Godspeed.